this is the main subject of this presentation, the history of the Greek DE59 cipher machine. So before I start, some acknowledgements. So first of all, to Jerry McCarthy of the National Museum of Computing for giving me the opportunity to make this call, to make this presentation here. So thanks a lot for that. Also, I had done another version of this talk for the ICCH, the International Conference on Cryptologic History. And again, thanks to the people that you see listed here for that. And finally, and probably the most important for this talk, is the Association of Retired Signal Corps Officers Museum, that they are the ones that had those devices available. As far as I know, the only one in public display are there. And they helped tremendously in this this research. I would say without them, that research would have been impossible. So starting with the history, we start with this person, Alex Delmouzos, born in 1880 in Amphissa, Greece, and he studied engineering. He was a person that was really into improving himself and becoming a very well-rounded professional. He was very interested in psychology and general, let's say, education, but for some reason he was forced to move to engineering where he started his career. Eventually, he managed to get to Germany where he could study what he loved the most, which was education and psychology. And a few years later, he came back to Greece and established one of the first academic institutions in Volos. In 1909, he briefly moved to Switzerland, and here you can see him with his wife. That unfortunately, we don't have almost any information about his wife. But his deep interest into the education systems led him in later years to become the co-founder of the Education Association of Greece and start establishing more schools and setting up the foundations on universities and how the educational system should work. And he became later on the Nafplios City's municipality education director. However, due to the political situation in Greece back then, and there was some political disputes, mainly because the political system wanted to use the education system in their advantage to promote certain ideas, and he was more against this. He was like, okay, the academic system should be academic, and they should not have any ties to political matters. So eventually, he set it up. He set up many more academic instances, including some universities. And in 1937, he quit from the Aristotle University of Thessaloniki, where he was actually a professor there. In 1938, he moved to Athens to become a government advisor on educational matters. And in 1946, again, due to some political disputes right after the Second World War, he decided to step aside, and he died in 1956. You can find statues like the one you see on the right side in various places around Greece, huge contribution to the educational system. Even today, some of the things that he established exist to this day. And he had 2 children, and this is where our story starts. And I want to highlight this person because it gives you an idea of in what kind of environment those 2 children grew up. So although we're talking about some very early days, they grew up in an environment where education was highly regarded. And this is why those people, both of them, the 2 brothers Delmouzos, started early on with sciences and engineering studies. One of them, Panagiotis Delmouzos, that was born in 1910, had studied electrical engineering, and he was working in the Navy as a radio operator in 1935. And together with his brother, they designed some circuit for radio devices. And he was the main designer, but his brother also helped in a lot of manners in this effort. And they created a company that you see on the right, one of the advertisements they had, that was called ELVIRA. And ELVIRA, although it was also a female name in Greek as well as in English, it was also an abbreviation for what you see on the bottom, that is the Greek radio industries. And they started building commercial radios that a lot of households were having. So nothing really special at this point. They were still continuing their education progress in different academic institutions in electrical engineering. And it was more or less a normal life until Second World War happened. So when this happened, due to all of this background and involvement with government and growing up in this kind of environment, they joined the SOE forces to stop the Axis from moving in Greece. Specifically, the second brother, Algis Delmouzos, initially joined the Force 133 of SOE, that it was named Apollo, the Apollo cell. And initially, he was just a radio operator, purely because of his background, but eventually he ended up being the leader of this cell. And the SOE code name, it was the one you see on over here, the AHS-22 Stuxi. And on the book you see on the right, The Secret War, there are extensive references on some of the operations they were doing and how they contributed to this organization. Now, his brother was, let's say, initially in and out of this organization. So I'm talking about Panagiotis in this case. Mainly, he was supporting on anything that had to do with radio communication. So let's say providing any sort of equipment they needed, any sort of logistical support, and building some custom equipment that they needed sometimes, like some spy antennas and spy radios. But eventually, he was fully merged into the organization as well. Now, what happened also around the time is that the Greek military was using communication equipment from Lawrence AG. So in 1940, ELVIRA, since they had this, let's say, paramilitary activity happening on the side, they came up with a new design for military radios, and they promoted the Greek military, and some of them were accepted, and 10 of them were even delivered to the 19th Mechanized Division. I had the opportunity to talk with a person that saw one of them, but I couldn't find any photos of that to include in here. So what you see on the right, the photos are some of the commercial radios that ELVIRA was building around that time. So those are systems anyone could buy for their homes. So in 1944, things didn't end up that well, since Germany figured out that ELVIRA had this, let's say, covert operation side of it in its factory. So they seized the entire factory, destroyed everything. But thankfully, due to intelligence that the two brothers had, they managed to escape just in time. However, the around 110 employees that the factory had at the time, well, were now unemployed, and they had no idea on how to move on with their lives. However, some good news is that after the war ended in 1946, the British government, in a covert manner, held back those two people, set up again the ELVIRA factory, and continue building some of those devices. Also, at the same time, the, let's say, main person that was designing those systems, Panagiotis Delmouzos, completed his PhD in electrical engineering. And around that time, due to his research, he also started looking into more of the secure communications. So what are the means to make radio communication more secure, apart from what he had already learned from being in that SOE group during the Second World War. And the thing that, let's say, light up the light bulb over the Panagiotis Delmouzos' head was the paper you see on the right side. So this study by Claude Shannon from the Bell Labs, it is the communication theory of secrecy systems. And what it proves in this one, it is more or less the concept of the one-time pad, that it is mathematically impossible to break it unless you have a significant flow in those pads, or you have access to the pads. And having this information, he started looking to how this could be applied in a radio communication system. So here I'm going to take a very short break to talk about something else that was happening around the same time in Greece, and that is the establishment of the first formal intelligence agency. And you will see later on why this is important. So in 1944, the person you see on the right, Thomas Karamessinis, he was a Greek American, and he was working for the OSS, the Office of Strategic Services of the US. And in 1947, as probably you know, OSS got restructured as the CIA that we still have to this day. So this person, being a Greek American, he was assigned in 1946 to 49 to be present in Greece, in the Greek desk, as it was called back then. And after the Second World War and the Civil War in Greece, he became the first CIA chief of station for Greece. And that was in the early 50s. The main tasks that he had from the CIA since now it was a CIA, not longer OSS. It was first of all to find any sort of communist activity among the military and government entities of Greece, and second of all to help Greece set up the first modern national intelligence agency. Up to this point, there were a few random, let's say, efforts in different organizations, but there was no central agency. And the first one was created in 1953. It was called the Central Intelligence Agency of Greece, or KYPE. And he was the person that, let's say, created most of these foundations, like setting up the hierarchy, the selection process, training, and so on. Now, why is this important? Because now we are going to move into the history of the DE59, the device that this talk is about. We are talking like in 1953, this is the year that this intelligence agency was created. And literally 2 years later, the Ministry of Foreign Affairs created the first project on how Greece could have secure communications for its intelligence agencies and diplomatic missions around the world. That research project was assigned to ELVIRA, and more specifically to Panagiotis Delmouzos, purely because of all of his contributions until to that point, since it was a very trustworthy person, and he had clearly expressed the interest to do that. So ELVIRA, the company, however, was not doing that well, especially with many new imported radio systems coming in from all over the world. So the business got reduced, and eventually they ceased all operations. However, this didn't stop Panagiotis Delmouzos from finishing his implementation of a device to implement a Shannon's theory on the one-time pads. And that was done by the end of 1959. And this is why the device that you see on the right, it was named the DE59. D is from his last name, and 59 from the year that the device passed all of the tests and became fully operational. Now, what happened later on is that in 1960, the Hellenic Army General Staff, with help from Delmouzos, created the Center for National Defense Research. Up to that point, there was nothing like that, and he was set up to become the head of that. So he was heading any sort of research that had to do with secure communications and cipher devices. And there were, from the moment the project started in 1955 to create this device to 1959 that we had the final version, there were around 3-4 different variants of this device that they were being tested. But it was only in 1960 when that device was testing in the field, like actual diplomatic missions, that were seeing if their communications was being intercepted. And the two embassies that were selected for that, it was the Rome embassy in Italy and the New York City embassy in the US. Those evaluations were very successful. So 1 year later, in 1961, the Greek government passed this device to the US government for evaluation, and to also eventually get it to NATO, to get it approved for all sorts of NATO communications. So in 1962, NATO officially approved this device for military communications of all classification levels. And this is the starting point when we start seeing this device being employed everywhere, like diplomatic missions, military communication centers, and intelligence agencies, anything you can imagine. Now, talking a little bit about the operation of the device, it is pretty simple, let's say, on a logical level, on how it works. You need one of those devices on each side, and you have a shared OTT, one-time tape. You load this tape to those devices, and from that point on, they continuously use this tape to encrypt and decrypt the messages. It is exactly the same device for encryption and decryption. You just have to flick a switch to switch the different mode. And that was for teletype communications back then. Now, and you needed also a transmitter in between. Now, the downside of this one, as I mentioned, it was for all communication in military, police forces, Ministry of Foreign Affairs, diplomatic missions, intelligence agency, everywhere. Now, the downside of this setup is that this is half duplex. So you can transmit and receive, but not both at the same time. So Panagiotis Delmouzos came up with an architecture that allowed full duplex, that it is pretty much duplicating the setup. So you could have two devices with an OTT tape, a different OTT for reception, a different one for, well, a different one per pair, let's put it that way. And in this way, you could have one continuously transmitting and the other continuously receiving, and the other way around, of course. Now on how this device looked like and what made it quite popular for many years, it was its modular setup. It was set up in a way that can be easily maintained, and specifically it had an aluminum case that you see on the left side, and the heart of the device was the 11 slots you see on the rear side, and those 11 slots had 11 modules for different operations. So for example, let's say one was the encoder, the other it was the unit that was controlling all of the switch and knobs that the device had, the other was the reader for the OTT. So if you had any issues, you could easily just replace this module and restart using the device immediately without having a lot of troubleshooting. The 12-pin adapter that you see on the left side, it was used to configure the device, and I will have more details in this one later on. And yeah, then we have the front panel, the frame, and the power cable, so nothing special apart from those. Now, this is the front panel of the device. We have on the left, of course, the feed for the tape, then 12-pin socket that it was used to configure the device with the reader that it was shown in the previous diagram. And then you had a couple of switches, the sensitivity, the transmission power, and on the lower side, you see that it had multiple connections. However, not all of them were required. Those were used, they were available so that it can be used with different kinds of transmitters and teletypes. So going into more details, those are two switches that are kind of useful to know. The T1 and T2 as they were mentioned in the manual. So the T1 had the modes you see, like unencrypted communication, controlled encryption. And what controlled means in this context, it was that before the transmission was, before the data was transmitted, there was actually a parity check. There was a validation that they are correct and there was no mistake in the encryption process. The uncontrolled, of course, it means the opposite, that it is a faster method that they are sent without this additional check on the encryption. And on the T2, it is the transmission mode, which could be continuous transmission, continuous reception, alternating transmission and reception. Now, the important part for this device was, of course, the OTT. In Greece, they were referring to those as the sets, and you can even see it written down on this reel that you see on the right side. It says in Greek set, and those were metal, and inside they had the tape, the one-time tape. Only two of them were produced at each time, two identical. And it is still classified to this day on how those were produced and where they produced. However, they look identical to the ITA2 code. So like 5 lines with dots. The concept how those were used is that they were distributed through a secure means. So let's say, for example, military posts to different locations. They were loaded, and there they were continuously used until they were running empty. So in some cases, let's say if there was a lot of communication, that could be a day. In other cases, it might be like 2-3 days that they were working until they had to be replaced. So the protocol was not to replace them like other devices, like every day or every specific, let's say, interval. It was until the OTT runs out of tape. Those photos again are from the same museum. All of the photos that you see in this part, and through that museum in Greece, I managed to get in touch with some people that actually use those devices for some time. And what they told me is that they were very easy to use, especially since, as you showed, they had very few options, so it wasn't a lot of let's say configuration to set them up. And the only thing they required to repair is some oil in the feeder, the tape feeder, replacing any light bulbs that they might had. They might were burned, since we're talking about the 50s and 60s. Cable replacement, especially in military settings, that someone might step on it and cut it. So very simple things. And the last part that it was explicitly highlighted to me it was the module replacement that it was what made this device so popular among the communication experts in Greece. It was really easy to figure out that a certain component was not working, and without any further troubleshooting, just take this out, put a new one in, and continue operating the device. Of course, there were some downsides as well, with the biggest one being that it was sensitive to teletype interference, especially when it was used with a UHF or line-of-sight radio teletype transmitters. This is why it had also the ability to change the sensitivity and the power of the transmission, since depending on where the communication was happening, it had some interference issues. And there is also the power setting for the power line fluctuations that it was having some issues with that. Another thing that people highlighted to me about this one is that even today, although they have like decades that they haven't used this device, they still recall the distinctive sound of the feeder that was making like a very rhythmic clicking sound while loading the tape. Okay, so inside, when we open it up, as you can see, the front panel, it can be easily removed. It is connected through a 16-pin connector that you see over here. It didn't require any special tools. It had a key, like a real key that you had to use to open it up on the side, and then you could remove it. And this way you had access to the 11 modules. So you could maintain the device and replace any faulty modules. Now, this is the front panel of the device, and as I mentioned, there were a couple of different variants of this one. So the panel looks the same, although they had, let's say, a few more options or a few less options, depending on the version that you had. But apart from that, all of the knobs and switches are the same, and all of the connectors are exactly the same. The tape was fed into that side, and on the left side, we had the connectors for the transmitter, and on the right side, the teletype. And to get an idea of how this looks like in practice, this was a real setup with a TT76 teletype and a TT4 transmitter. This was how it was typically set up in either embassies or military communication centers, or any sort of, let's say, Ministry of Foreign Affairs center that needed to have this communication setup. And here we can also see that the OTT is loaded, so you can get a better perspective on how the device looks like with the OTT in place. Now, this is the manual of the device, and it was classified. Actually, this was declassified very recently, like a couple of years ago. Until then, it was classified as secret, and it was from the Army General Staff Third Office that was producing those under the designation TE. That TE means technical manual. They are the initials for technical manual 9411. It is technical manual for communications, and the official name that the device had, it was Online Cryptographic Device DE59. And this specific manual is from 1961. What I learned from some of the people that were in the military and were using those devices is that although we have no, let's say, public information on how many of those devices were ever produced, we do have information that there were around 1,500 of those manuals that were printed by the military printing office. This doesn't give us a like one-to-one correlation with the amount of devices that they were built, and also it is not clear if there were other agencies that were building their own that were printing their own manuals. This is unlikely, but yeah, it is something that we cannot rule out. So yeah, it is a number that it can help us give like a guesstimate on the amount of devices, but to this day we don't know how many of them were ever produced. Now, taking another break to talk about something else happening around the same time in Greece. I'm certain a lot of people in here are familiar with the 2018 release of Crypto.eg that was more or less controlled by the German and the US intelligence agencies from 1952 until 2018, more or less. And in there, especially in the articles published by many reputable journalists, they also mentioned that Greece was part of this of the customer list that could be affected. I found this document from the NSA archive, the online archive from William Friedman's archive, that was from 21 to 28 February 1955, and it was more or less a summary of how the sales of crypto EG devices are going in different parts of Europe. And it was a report to the NSA to get an idea of where they are today. And in this report, we have this part that says Greece and Turkey have been given literature and they are interested in those devices. Okay, that's the first sign that both Greece and Turkey were interested in crypto EG device around the same time, more or less. We're talking about 55, so it is literally almost the same time. And there is also this one over here from the same document that it was listing different cipher devices that they were used by different countries based on the salesmen of crypto EG that they were trying to sell their device to those countries. And in there, we're reading that Greece is listed on the lower part as using Siemens and crypto EG together, and other similar countries were Spain and Denmark. Now, what is interesting is I talked with a couple of people that were in the Greek government, and they were operators of cipher devices around that time. And what they told me is that at least in the military, there was no crypto EG device anywhere in the Greek military around that time. So we're talking about the entire 50s and 60s throughout like the whole period. And I also got the same thing from people from the Ministry of Foreign Affairs that they didn't use any crypto EG devices. Now, what I was unable to find is if there were any of those devices being used by the intelligence agency on any specific, let's say, diplomatic mission or some other entity. However, in the military and the Ministry of Foreign Affairs, all of the people that I talked with said that there was no such device present. Most of them were either using some very old manual method, or they were using the device that we're talking about here, the DE59. Now, do we know of any cases of people trying to break the DE59? Unfortunately, not that many, and I hope to find out more. I'm continuing this research, so if anyone has any insights in this one, please let me know. But what there is out there is this book that it became, let's say, popular for good and bad reasons when it was released. It was released in 1987. It was from an MI5 senior intelligence officer. And the reason why it received both sides, let's say, good and bad reputation is that it gave some understanding of some of the operations MI5 was and MI6 were running, but at the same time, doing that, yeah, it also received a lot of negative impact as well. So yeah, it is both good and bad. Now, for this specific case, there is an interesting part talking about the Cypriot War of Independence, where on one side it was the United Kingdom and Turkey, and on the other side it was Greece and EOKA, that was an organization in Cyprus, a paramilitary organization. So in this book, what we are reading, it is in, I think, page 195, if I remember correctly, where the author says that the GCHQ was unable to intercept the communication between Cyprus and Greece. And we do know now that Cyprus and Greece were both using DE59 for secure communications. So that means that at least GCHQ tried to intercept it, at least that. And they sent the author together with a couple of more people to more or less wiretap those teletype and telephone lines, so that they have like direct access to try to intercept the communications. Now, what is not clear from the book is it is very clear that the wiretapping was successful. Like, it is super detailed to the level of they were talking about how they went to the night, how they climbed up to the pole, they installed the wiretaps, like super detailed. But what is not mentioned anywhere in the book is what happened afterwards. Like, were the cryptanalysis successful? Did they manage to break that or not? So we know that there was this effort, at least, but we have no idea if it was ever successful or not. Another interesting fact talking about books is from this. This, unfortunately, it's only available in Greek. The title of the book says, "I was a London embassy cryptographer," and it is from a person that during the Second World War, and during the later stage in, let's say, early 50s, he was a Cypriot Greek that he was assigned to the Greek embassy in London, and his job was to be a cryptographer. So he talks more or less about his experience and how he was operating there and what he was doing. And in one of the very early chapters of the book, he was talking about the 1940s, so still we're talking like a decade earlier. But he mentions that when he was getting trained as a cryptographer, he was provided with a lot of translated documents that on how different countries were doing cryptanalysis, and that included documents from the US, Russia, Japan, but mainly from the United Kingdom. So that means that at least a decade back, Greece had some idea on some of the crypto code breaking, let's say, capabilities of the UK. But again, we don't know if that played any role in the design of DE59, or if that was even relevant 15 years later when the previous case happened. However, yeah, it is something worth noting that at least a few years back, there was some knowledge around this. Now, from all of the people that I talked with, a few of them mentioned this thing that we cannot give you any evidence about this one, that there were signals intelligence agencies going after this device to try to break it. But what we can tell you is that if there was any of them, it could definitely be those two. This is, I'm just, let's say, passing this information without any sort of evidence. They said that those are the ones that they were typically interested in these kinds of operations against Greece around that time. However, due to that being an OTT device, a one-time tape device, a more likely scenario is that they will try to follow a traditional espionage approach, which means either recruit someone that has access to the unencrypted messages, or try to get access to the OTT so that they can decrypt it as the messages are being sent. Yeah, unfortunately for this one, there are no evidence, so it is purely what people told me about that. And moving to the end of the device, in 1990s, all of the teletype government communications were eventually decommissioned. And on the right side, there is a nice article that talks more or less about this from the Association of the Retired Signal Corps Officers Museum. So this device, after 40 years of operation from 1959 to 1999, it was decommissioned. However, it wasn't until 2019. So we're talking about 10 years later that this device was declassified and it is publicly available for displays in museums, and also to have access to information like this one, the manuals and everything I shared with you today. The only devices that are on public display, as far as I know, they are the ones in this museum, the Association of Retired Signal Corps Officers Museum. So yeah, if you ever get the opportunity and you want to see one from there, this museum is based in Athens, and if you need any help with that, reach out to me and I can get you any additional information you might need. Now, the most important person to mention and to close with is this one, Panagiotis Delmouzos, that not only did he do all of this kind of covert work during the Second World War, not only was he the inventor of the DE59, he was also the person that created this research center in the Greek military that exists to this day with a different name, but still exists to this day and does this kinds of research. And unfortunately, yeah, he passed away in 1985, and his name was really unknown. Even to this day, there are very, very few references to this person, although he played a key role to secure communications in Greece. And with this one, I want to thank you. And yeah, if you ever consider donating something to a museum or want to visit a museum around secure communications in Greece, please let me know and I can get you in touch with those people. They would be more than happy to give you even more insights than what I did with this one. So yeah, thanks again. And if you have any questions, please let me know.
Polly Kale, Kayacharisto Polly. And are there any questions? I see a raised hand.
Okay, can you hear me okay, Jerry?
Yes, I can.
Okay. Thank you for an enlightening talk. I'm interested in that the DE59 was submitted to the US for evaluation. Given everything that we know in respect of crypto AG and the technological capability, do you know anything about what that evaluation related to, and do you have any sense that the US might have understood any weakness in the machine?
Absolutely. Yes, so first of all, for the US, the evaluation was so that the device can be used with all sorts of classified communication, and it was also the US that eventually passed it through the NATO evaluation. So it was for this part of the work. Now, if the US managed to find any flaws, actually, I recently sent the Freedom of Information Act to the NSA for exactly that. So I haven't received the response yet, so I have no idea. But maybe if they respond back to me, I will know in the near future, and I can have a follow-up session on what the US knew about this device. Something that it was raised in the ICCH when I did this, well, a similar talk to this one. It was that there might have been any tempest flows, like any emissions that the device had, especially considering that some of the operators mentioned about this clicking sound that it was making. However, yeah, that's just speculation at this stage. So depending on the response that I will get from the NSA, I might be able to answer that in the future.
Okay, thank you. I had a follow-up question, which is, do you have any idea of the speed of transmission? Clearly it was a mechanical reader for the OTT. Do you have any understanding of the speed of its operation?
Unfortunately not. I could find out from that manual. I'm certain it's there, but yeah, I don't know. Yeah, I don't have a number now.
Okay, thank you. It was only a small point. It was nothing. Yeah. Thank you.
Presumably it would just be running at typing speed, would it not?
Well, we don't know whether or not there was any way of actually loading a tape, for example, into the transmission side, preparing a tape in advance, or whether or not.
I see what you mean.
Yeah.
So you mean a bit like the SZ42, for example?
Yes, or yes.
Any other questions or points?
Well, I've got one more then.
Go ahead.
Well, it's only we know that lots of cipher machines, once they're decommissioned, have been destroyed. Obviously, you said that there are examples of the DE59 in the museum that you referred to. Do you have any idea what happened to that potential stock of 1,500? Were they destroyed? Any further information on those?
No, whatever those in the museum, there is no public mention on how the museum got them. There is just that in 2019 they were donated, but there are no further information. So yeah, I don't know. Even the 1,500, this is the amount of manuals. We don't know how many devices, how many DE59 devices are there.
Sure. I'll stop asking questions now. Thank you very much for a great talk. Thanks, Jerry.
Thank you. Well, usually, as you mentioned, those are typically destroyed. So this is my assumption, purely my assumption, that probably the military gave a few of them to that museum just to preserve them, and the majority of them would be destroyed.
Okay, well, it seems there are no further questions. So in that case, I shall prepare to close this call. I will just replace your share with my share. That's what we've just been listening to, of course. And coming up next on Wednesday, we have Peter Runyon, a volunteer at National Museum of Computing, who's going to talk about the ELA 803. And then on Wednesday, September 8th, I'll be talking about 4 or more interesting Enigma-like crypto machines. I say 4 or more because I haven't quite worked how many to speak about, but I will be including a Hebrew Enigma machine, a Polish Enigma-like machine, and a Japanese Enigma-like machine. And then finally for September on the 28th, I have Chris Christensen, Professor of Mathematics at the Northern Kentucky University, who will be giving us a second talk about 3 Japanese naval crypto machines, the Ika, the Orange, and the Jade. And with that, I say thank you very much once again, Anastasios, and I shall close the call. Thank you very much, everybody, for attending.
Thank you.